What's up, mathletes? This is section 2.8, systems of equations in three variables. And I gotta say, I'm kind of geeking out right now because check this out. I got a new microphone. I hope it improves the audio. So how's this for a freaking audio check? I want you to tell me, is it better or worse or stays the same audio? What's the sound quality like? Let's check this out. Systems of equations. So there's a lot of handwriting. I'm not going to lie. If I'm going too fast, feel free to pause, as always. But we're looking at systems of equations in three variables, and that means we need three equations in order to guarantee we can solve it. So I'm going to go red, blue, and gold. Check this out. My attention is immediately drawn to the fact that here we've got x and y and z. What's up, z? Hey, how we doing? It's a new variable. Say hello. Yeah. Okay. So, and then also here's a fun fact. It's always easiest to start with the equation with the fewest number of variables, if there is one. So check this out. If you know that negative 2z is equal to 8, then boom, you can just say that, oh, I know that z is equal to negative 4. And all of a sudden, if you do that, you can plug it into the other equations. Oh, look at this. If you know that z is equal to negative 4, then you can plug it into the blue equation. And rewritten, it's no longer has a z in it. It has negative 4, and then you can solve that. You multiply 6 times negative 4. You add the 24 to both sides, and then you undo the multiplication, and you get y is equal to negative 6. And then now if you know that z is equal to negative 4 and y is equal to negative 6, you can plug that all into the golden equation right here. So that's 3x minus 2 times what you know y is, plus 2 times now what you know z is, equal to 10. Rewritten, and now we can simplify all the way down, and we get x is equal to 2. How cool is that? Reporting your answer in alphabetical order. This is the x value, the y value, the z value. A, B, C, D, E, F, G. All right. I'm just pretty stoked about this microphone. Honestly, I'm in a really good mood. All right, so example 2. Now check this out. This is it's a little more complex because all of a sudden we don't have like in the first example, we don't have an immediate obvious first step. Like the z was it's right there, just go get it. But now we have each equation has x, y, and z. So we're going to use a trick that we learned from before. One thing that I noticed, and this is not the only time that this occurs, like if you were to add, we're going to add the blue equation and the red equation together, and we're going to get another equation. But in order to do that, I think what I'm going to do is I'm seeing that x is, you can divide the blue equation by a greatest common factor, which is 2. They're all even. All these numbers are even the number over here. So I'm going to multiply it by 1/2 or divide it by 2, and I get this. And now because x is now all by itself, the coefficient is 1. It's not all by itself. The coefficient is 1. It's not 3x or 2x. It's just x. You can see that I'm going to multiply this entire equation by negative 4 and add it to this equation. If I do that, then I will eliminate the x's from the red equation. I'm also going to take the blue equation, and to eliminate this gold 3x, I'm going to multiply the blue equation by negative 3 and add it here. That will eliminate the x's here as well. So when I do that, x times negative 4 plus 4 is negative 4x plus 4x is nothing. It gets eliminated, 0x. Negative 5y times negative 4 is 20y, plus y is 21y. Negative z times negative 4 is positive 4z, plus 6z is 10z. Negative 4 times 24, negative 4 times, 6 times negative 4 is negative 24, plus 12 is negative 12. So that's how we get the new version of the red equation. And then, let's see, we're multiplying the blue equation by negative 3. So 3 times, x times negative 3 plus 3x is nothing. It's 0x. It gets eliminated. Don't have to write it. Negative 5y times negative 3 is positive 15y. Added to 8y, you get 23y. Negative z times negative 3 is positive 3z plus 19z is 22z. 6 times negative 3 is negative 18, plus 38 is positive 20. All right, so now that we've done that, what we do have is the red and the gold equations no longer have an x in them. And now, if we just forget the blue equation for a bit, we have two equations and two unknowns, and now we've spent like several days trying to figure out exactly how to solve those. And so I'm just going to rewrite them together. Oh yeah, and now this looks like a previous section, elimination. And so I think what I'm going to do is I'm going to consider like the least common multiple of 10z and 22z is going to be, let's see, we're going to get on negative 110z. So what I really need to do is multiply this by 11. Yeah, that's what this is right here. Multiplying this by 11. And when I do that, oops, here we go. When I do that, okay, so I get 21y times 11 is 231y. 10z times 11 is 110z. Negative 12 times 11 is negative 132. 23y times negative 5 is negative 115y. 22z times negative 5 is negative 110z. 20 times negative 5 is negative 100. And so now you can see that there is 110z and negative 110z. When I add these two equations together, I get a new equation that has no z variable in it. I just have 116y is equal to negative 232. And so you can see here y is equal to negative 2. Now that we know that one of the variables is, we can plug it back into one of these equations right here that only has y and z. Don't plug it back into one of the original because it won't help you figure out what z is. But if you plug it back into this version right here, this equation, you get 21, and we now know that y is negative 2 plus 10z is equal to negative 12. And if you solve all that and eliminate, then you get z is equal to 3. Then, now that you know that y is negative 2 and z is equal to 3, we're going to take those values and put them into the original, not the original, I guess this easier version of blue right here. You can plug it into the original if you want, the original blue, but in either case, you get x is equal to negative 1. So, reporting x, y, and z looks like this: negative 1, negative 2, and 3. Yeah, it's a doozy. There's a lot of work here. Each of these problems takes a while. And if you're going to do the word problem version of it, you got to really get organized. Example 3, memberships. In 2016, the Dali Museum in St. Petersburg, Florida, offered individual, dual, and family. Wait a minute. There's three things here. It looks like it's going to be 3 by 3, which cost 60, 80, and 100 respectively. Suppose in 1 month the museum sells a total of 81 new memberships for a total of, I'm seeing the word total of 81, total of 6420. The new number of dual memberships purchased is twice that of the individual memberships. Determine the number of new individual memberships X, dual memberships Y, family memberships Z. The word problem even specifies X, Y, and Z. We got totals of 81 new memberships, and then 6420 is the dollars, and then dual is twice the individual. That's going to come up as an equation as well. So total is 81, and we're just adding x plus y plus z. Then the total money is right here, and then you see the prices per membership, respectively. Y is equal to 2x. That's because the dual is twice individual. Dual is twice individual. All right, now we're going to figure out how to solve this. And I think what I'm going to do is I'm going to just use a straight up substitution. If I know that y is equal to 2x, then I'm just going to plug it in here and here. And rewriting the red equation, you get x is equal to no longer y, but 2x plus z. That's from this, is equal to 81. And then I'm going to plug it into the blue equation as well. I get 60x plus 80, no longer y, but now 2x plus 100z is equal to 6420. You simplify these down just a little bit, now you get to two equations, two unknowns. We got tons of techniques for that. And I think what I'm going to do is use substitution again, because z could be all by itself kind of easily in one step. Z is equal to, if you're subtracting 3x from both sides on this red equation, then z is going to equal 81 minus 3x. You plug that back into the blue equation, substitute it in, and now you get 220x plus 100 times 81 minus 3x is equal to 6420. Simplify, simplify, simplify. And where did I simplify? Did I simplify? Oh no. Wow. Boom, magic, there it is. Okay. So you can see we've got, we're plugging this in. Z is equal to 81 minus 3x. That's an equation I got from here, rearranging that. And then what 220x plus 100 times now what Z is equal to 6428. I can distribute and solve, and I eventually get x equals 21. Once x equals 21, I can plug that back into the Z equation to find Z. Z is equal to 18, and the Y equation, Y is the original golden equation at the very top. Y is equal to 2 times 21 is equal to 42. And reporting my answer looks like this: X, Y, and Z. Let's do another example. So we've got the red, blue, gold equation here. I'm looking, my eye immediately goes to this x right here. If this were a 3x, maybe I would use the negative z. But knowing this, what I can immediately do is go to elimination. I'm going to take this x, and I'm going to use this x to eliminate the red x by taking the blue equation and multiplying it by -2 and adding it to the red equation. Same thing, I'm going to take this x and use it to eliminate the x's in the gold equation by multiplying the blue equation by -3 and adding it to the gold equation. When that happens, what I do is I get x times -2 is -2x plus 2x is nothing, gets eliminated here. -2y times -2 is positive 4y plus 3y is 7y. -4z times -2 is positive 8z plus -z is positive 7z. And 14 times -2 is -28 plus 0 is -28. X times -3 is -3x plus 3x is 0x, not written. Y times -3 is -3y. Sorry, backtrack. -2y times -3 is positive 6y plus y is now 7y. -4z times -3 is -12z plus -8z is positive 4z. 14 times -3 is, what is that? It's -3 times, it's -30, that's 42. -42, -42 plus 17 is -25. And so now I have two equations and two unknowns. And I think what I could do, as an alternate, if you wanted to, you could divide this equation by 7 if you want, all the terms on both sides to get kind of something to substitute. But I think I'm just going to say, since this is 7y and this is 7y, I'm going to take the red equation, multiply it by -1, and so you get -7y plus 7y eliminates to nothing, 0. 7z times -1 is -7z plus 4z is -3z. -28 times -1 is positive 28 plus -25 is positive 3. And then undoing the multiplication, you get z is equal to -1. Great. Now that z is equal to -1, I can plug it into one of the immediate equations. I think I'll just take the top one, the red one, doesn't matter, you could use the gold. And I get 7y plus 7 times z is -1, so I'm going to write -1 is equal to -28. And when you solve that, you get y is equal to -3. Now that we have z and y, I can use one of the original equations. I'll choose the blue one because it's a little simpler. It has one less number in it. And plug in what I know and solve and get x equals 4. And there it is. 4, comma, -3, comma, -1. Example 5. All right, so it looks like we've got here these three equations. My eye immediately goes to the c. Oh, this is a very simpler equation compared to the others. There's only one variable, so I can knock out c real quick. C is equal to 3 because I undid the multiplication. Taking that and plugging it back into the two others, and this is what I get. And then I'm left with a system of equations, two unknowns, two equations. I can solve that. If you wanted to, you could have subtracted 2b to get substitution. A is equal to -2b, but I think what I'm going to do instead is use elimination. Multiply the gold equation by -2 A times negative 2 is negative 2a plus 2a is nothing. It eliminates. 2b times negative 2 is negative 4b plus 3b is equal to negative 1b. And 0 times anything is it's just going to leave you with what you have there, 1. B is equal to negative b is equal to 1. Multiplying both sides by negative 1, you get b is equal to negative 1. Plug them back into the original. I get a is equal to 2 times negative 1 plus 3 times 3 is equal to 9. And then I think you can figure out what a is equal to from here. And so report your solution. Again, it's in alphabetical order, A, B, C. Let's go to a word problem. A veterinarian wants to make a food mix for guinea pigs. I love guinea pigs. Squeak, squeak. That contains 23 grams of protein, 6.2 grams of fat, 16 grams of moisture. Whew. All right, the composition of the 3 available mixtures, they don't even list it out in the word problem. They just give you a table. This is a 3x3 table. It screams 3x3 systems of equations. The unknowns are just going to be A, B, and C. How much of A, how much of B, how much of C are we going to use? The totals are given in the word problems. 23 grams contains a total of 23 grams. Boom. 6.2 grams, 16 grams of all these. Each of these vertical columns can become an equation. So the protein is the vertical column, first column right here, protein column is red, fat, blue, gold, moisture. And look at all those decimals. Whew, let's get out of decimal land real fast. Multiply by 20 because that's the lowest number you would need. The 100, that's the lowest number you need here. And 20 also would work here because you can see it's just that you could multiply them all by 100, but then you get equations with really, really higher than you need numbers. So if you back it off a little bit and find the smallest number that will produce the smallest number that will get rid of the decimals, then that helps a lot. Because you can see now these equations here, way simpler to deal with. Had we multiplied this by 100, this would be 20a, 10b, and 15c. It's just easier to deal with smaller numbers. I think what I'm going to do is focusing, I see a C right here. The C has absolutely no coefficient. So that will make it a little bit easier to eliminate this blue C and this red C. I'm going to do that by multiplying this gold equation by negative 5 and the gold and adding it to the blue equation. Then we can multiply this by negative 3 and add it to the red equation. So what that looks like is you get so 3a times negative 5 is negative 15a plus 2a. This should be gold. This should be blue. Magic. Now it's blue. There we go. Okay, so 3a times negative 5 is negative 15a plus 2a is negative 13a. 2b times negative 5 is negative 10b plus 6b is negative 4b. And 320 times negative 5 is a big number. What is that? 1600. Negative 1600 plus 620 is negative 980. And then this gold equation times negative 3 will give you, let's see, negative 3a times 3a times negative 3 is negative 9a plus 4a is negative 5a. 2b times negative 3 is negative 6b plus positive 2b is negative 4b. C times negative 3 is negative 3z plus 3c gets eliminated. There's no c in the new red version right here. It's just, we don't write it. 320 times negative 3 is negative 960 plus 460 is negative 500. So now we got two equations, two unknowns. Look at this, negative 4b and negative 4b. I just multiply the blue equation by negative 1 and add it to the original, add it to the red one, and we get 8a is equal to 480. You can solve that to get a. You can plug a is equal to 60. If a is equal to 60, you can put it back into here and get b. Solving this, you get b is equal to 50. And if you know a and b, you can plug that into this version of the ABC blue equation, and you get this, and solve this for c, and you get c is equal to 40. Reporting your solution, there it is. If there is a big idea, it is this. Find and eliminate the variable that has a coefficient of 1. So you can rewrite just two equations with two variables, and then you use all the techniques that you used from before. Graphing is a little complicated in 3 dimensions, but it looks like planes like this. And if there is a single solution, like here, we got 2, -1, 3, that means you had 3 planes that all intersect with this tiny little red dot. Sometimes, and that is a consistent solution. There's like exactly one solution right here, consistent, independent. However, these planes can line up in lots of different ways. If equations 2 and 3 are very similar to each other, then like if they're just an identity and they're the same plane, just rewritten in different ways, then you can see it could look like this, or it could even look like and have an infinite number of solutions all along a single line. Or if 2 and 3 are the same thing and they're just parallel to plane number 1, then you can see there's absolutely no solutions over here. These are all the different possibilities. The planes could be parallel railroad tracks, except 3 of them, like 3 stories on a house, they're all parallel to each other. Then there are no solutions. Here, there's also no solutions because these 2 are parallel and this one intersects the others, but there's no one point that is in all 3 planes. Or you could have 3 planes that are all identities, all multiples of each other, and they're just 3 different versions of the same plane. And then you have another way of having infinite solutions. Here also no solutions, because although two of the planes intersect, every 2 planes intersects each other. There's just no one point that intersects all 3. That's fun. Check this out. And if you want fun, then let's go to Inspire. Whew, don't you know it? All right, this is going to be how we do 3 equations, 3 unknowns in the Inspire. All right, we're going to go to the scratch pad. That's A, calculate. Then we're going to type out solve. Remember, solve requires parentheses. We're going to go to the next to the 9, the frequently used symbols, and we're going to go over to left, right. We're going to go to the one that has bracket 3 with 3 spaces. Systems of equations. How many do we have? You can go up. You could do 5 by 5, but right now we're going to start with 3 by 3. And type in our equations. I'll do one from the example, one from the notes. Negative 2x plus 2y plus 5z, and then equals button, negative 3. Down. Let's type in the next equation. 3 times y. You could also just write 3y plus 5z is equal to negative 3. Down arrow. I hope you're doing this along with me, because I'm going to ask you to solve one of these. Negative 3z equals negative 9. Right arrow. What are we solving it for? Comma x. Very important. If you don't do the comma x, comma y, comma z, it's not going to know what solutions to give you. Let's press enter, and that's what we get. It tells you x is equal to 3, y is equal to negative 6, and z is equal to 3. Let's do another one. Solve. Parentheses. Go to the frequently used symbols button. Create a systems of equation. Your cursor might already be there. And let's type out some more equations. X plus y minus z is equal to negative 1. Down arrow to get to the next equation. X minus 2y plus z is equal to 7. Down arrow to get to the third. Negative 2x plus 2y plus 4 z is equal to negative 4. What are we going to solve for? You have to tell it. It's not obvious to the Inspire for whatever reason. You got to tell it, oh, and I want the answers to x, comma, y, comma, z. Close parentheses. Enter. And I want you to tell me, I want you to press the enter button and tell me what the answer is. Take care. Thanks for playing along. I'll see you in class.